So that's the new thing today, okay? It has to work for any positive. What happens? If x is close enough to a, did we say that? And again, we have to introduce delta properly. How do we do that? Not suppose, but okay. There's some delta. There exists delta greater than 0, such that what?
The absolute value of x minus a. Oh, it's not really.
It's
sorry,
right,
it
yeah.
avoids a little dirty. So
I know. If absolute x minus a is less than delta, then what?
F x minus L less than x.
Absolute value of x minus L is less than x. Okay, and the only thing that's missing here is what? Again,
one
this.
equal.
Huh? But unequal, right? So how are we going to phrase that? I should just throw something in here? One extra thing to make that work. But
X doesn't equal F.
x doesn't. Okay, that'll be fine, right? So this is this is basically the definition of limit, right? And so we basically proved here that the limit of x squared is 4, right? So now, just a bit of notation here. It's a little awkward to write but x not equal to a. It makes the definition as long enough as it is without adding. So let's try to make it a little simpler. I'm just going on the right side, right? B u but equal to. That would be, you know, over here we can do something else. So what we can do is if x equals a is the same thing as saying that the absolute value of x minus a is what? Right, equals 0, right? In other words, to say x equals a is to say that the distance from x to a is 0, right? Or I could even put in an extra step. That's the same thing as saying x minus a equals 0. It's the same thing as saying the absolute value of x minus a, right? So, to say x is not equal to a is the same thing as saying that absolute x minus a is not equal to 0. Sorry?
Greater than 0?
Greater than 0. Or not 0, but actually greater than 0. So I can make this even simpler too. All I have to do is write here that absolute x minus a is more than 0, right? And then we're all set, right? Okay, so then that is the traditional definition of limit. Okay, well let's now prove that this function, show the limit of this function as x goes to 2 is 4. Well, it's basically the same proof as what we have on the board here, but maybe just a little more complicated. All right. Okay. So we'll just apply the definition. Say Mr. Epsilon prescribes a tolerance so this is going to be like a proof, okay? I'm proving this. If the limit of g of x is 4. Okay? Say Mr. Epsilon prescribes a tolerance, we must show, and I'm just going to write down, say prescribed tolerance, we must show whatever it is, if x is close enough but equal to absolute x, well, x squared is tolerably close. No, not x squared, but rather what? D of x. D of x is tolerably close to 4. All right, now this is not a proof. I have to make some changes, but they're minor changes, so I'll just leave this up here for the time being. Still going to note this. Okay, that's, what do I write here?
Epsilon is greater than 0.
Okay, very good. Okay. Now, again, we have to do this for all epsilon, every epsilon, right? But it's okay at first just to take epsilon to be some positive number, right? So in other words, we'll just fix an epsilon, okay? We'll fix any epsilon. And this has to work for every single epsilon. So that's the point. All right. So say epsilon is greater than 0. And so now we must show what? Again, we can just copy what it says here. Well, okay, we can make it. We must show that there exists a delta greater than 0 such that if what? 0 is less than absolute x minus a is less than delta. I'm just copying from over there. Then absolute value of g of x minus 4 is less than x, right?
2 instead of an a.
2. Okay, now all right, so we got here, all this is fine. I still want all this work, but now what else do I need? Well, this isn't exactly, see, this is x squared minus 4, which is all well and good, but that's not, g of x isn't x squared, right? At least not all of it. So, to finish the proof, I want to say it is d of x, right? Provided x isn't 2, right? In that case. So if x is close enough to 2, both happen. And then I'll just break one more line. If also x doesn't equal 2, then we have this, right? And I'm allowed to do that because, again, I don't care. X is not supposed to be 2. And I don't care what happens when x equals 2. Okay? Doesn't matter. So it's also here. So, and instead of here, I'm going to have not this, but rather, instead of absolute x minus 2 less than delta, I'll have